Hello, in a previous video I reviewed exponent properties. In this video I'm just going to work through a few examples. If I paste in our list of exponent properties here, you can see. And we'll just start with something simple. Pen tool doesn't seem to be wanting to work. Okay, there we go. Start with something simple that has to do with the product of powers property, which you might remember is this one right here. Okay, so say we're given x squared times x raised to the power of 5. Well, we know due to the rule of this property that this will equal x2 plus 5, which will equal x raised to the power of 7. Okay, so again, the product of powers property, you're just going to add the two exponents, in this case 2 and 5, which will give us 7. Do another example, say something a little bit more complicated. Let's say you have 2r squared times 8r cubed. Okay, it's the exact same premise really, except we're going to have to multiply this 2 and this 8 as well. So what this will equal, I'll write it all out, so you can see it'd be 2 times 8 times r squared times r cubed. 2 times 8 is 16, so this is going to be 16r 2 plus 3, right, as the product of powers property states. And so what we're left with is 16r raised to the power of 5. Okay, so let's do another. Maybe this one, the next one will think a bit about the quotient property. So let's just start with something simple. Say we have b raised to the power of 5 divided by b raised to the power of 4, which is the same as writing it this way. Okay, b to the power of 5 divided by b to the power of 4. And the quotient rule states, as we reviewed in the last video, and as you can see here, where a raised to the power of m divided by a raised to the power of n equals a raised to the power of m minus n. So in this case, it's going to be b raised to the power of 5 minus 4. Right, we're just going to subtract the exponents, 5 minus 4, so that's just going to be equal to b raised to the power of 1. But you don't need to write to the power of 1. You can just write it's just going to be equal to b. The 1 is implicit there. Okay, so we don't write it. It's the same with, for instance, you're taking square root, right? The 2 here, that's implicit. You don't always have to write it. In any case, let's do another one. Let's mix it up a little bit. Let's say we have here the quotient property. Let's still work with the quotient property, but we'll say we'll have x raised to the power of 5 divided by x raised to the power of negative 2. Okay, so it's a little bit of a little bit different, but it's in practice it's essentially the exact same steps. So it's going to be x raised to the power of 5 minus negative 2. Okay, and the double negative will be positive, so what this is going to be will be 5 plus 2. So it'll be x raised, and 5 plus 2 is 7, so x to the power of 7. Do something a little bit different, that maybe has us work with the power of powers property, which is this one right here. You might remember when a is raised to m, which is then raised to n, which equals a to the power of m times n. So we can use an example such as, say we have x raised to the power of 4, and then we'll square that. And then let's just throw in something extra. Let's say we multiply it by 2x cubed, just for fun. So how do we begin approaching that? Well, again, we just review our property of a power, which is right here. Okay, so this is going to simplify to, and actually I'll write the property out here just in case, just for reference. A m raised to the power of n is going to be equals to a m n. Okay, m times n. So in this case, it's going to be 4 times 2, so it's going to be x 4 times 2 times 2x cubed, and then that's going to be equal to x raised to the power of 8 times 2x cubed. And then, like as we did in a previous problem, we're going to have to multiply this 2, and there's a 1 here. It's implicit. We don't need to write it, just write x, but there is a 1 there, and actually I'll keep it there just for reference. And so it'll be 2 times 1, which is 2, and then we have our x, and it's going to be 8 plus 3, right? Because then this is just the product of powers property, 8 plus 3, so we're left with 2x raised to the power of 11. Yeah, we can do a few more examples. Let's say we have something, again, a little bit different. Let's say we have, I don't know, let's say we have x raised to the 6th power, which is then raised to the power of 2/3. How about that? Okay. Well, again, we just have to review our exponent properties, right? So this is a power of a power property, except we're using a fraction, right? So it's going to be 6 times, so it's going to be x. It's going to be 6 times 2, which is 12, right? So it's going to be 12 over 3, and then that simplifies to x raised to the power of 4, right? Because 12 divided by 3 is 4. Do another one. Let's say I'll write it here. Let's do again something different. Let's say we have minus 5 raised to the power of negative 3. Okay. Well, this is the same if we review our exponent properties. Remember this video, if you're raised to a negative exponent, it's going to be the same as 1 over a m, right? So in other words, a raised to the negative m is equal to 1 over a m, right? It's the reciprocal of the positive exponent. So in this case, it's going to be 1 over negative 5 cubed. 5 times 5 is 25, times 5 is 125, so negative 5 cubed is negative 125, and we can just leave that as it is, right there, 1 over negative 125. We'll do yet another different one. Let's say we have n raised to the power of 1/2. Okay, it's quite simple. Again, if we review our exponent properties, we know, and maybe I'll write it because the list is growing increasingly out of view, but if we have, for instance, I'll just write it here, a 1 over m raised to 1 over m, that's going to be the same as m taking the root of m of a, right? So in more simple terms, in this case m is 2, so it's going to be the square root of 9. You don't have to write the 2 there for square root. I mean, it's just, again, it's, as I mentioned earlier, it's implicit, it's implied, and the square root of 9 is just 3. So that's our answer. We can do maybe yet another different one. Let's say we have something, okay, let's say we have 49, slightly different, 49 raised to the power of 3/2. Yeah, okay. So again, it's a variation of what we've just done, in that this is a raised to the m power, which we reviewed in the last video, which is, you can see here, that's going to be the same as, again, you're taking the root of m, or m, and then a is going to be raised to the n power, right? So in this case it's going to be, well, m is still 2, so you're going to take the square root of 49, but that's going to be cubed. Okay, and actually I could have probably picked an easier example, but this is going to be a big number, So we're going to be taking the square root of 49 cubed is 117,649. Okay, and so now we're going to take the square, so that's 49 cubed. Now we're going to take the square root of this, which simplifies to plus minus 343. Do one more maybe. Let's say something completely different. Let's okay, yeah, we'll do one more. This is a good one to conclude. Let's say we have 25 raised to the negative 3 halves. Yeah, okay. So again, we just review exponent properties, and we've already worked through this, right? Where if we have a raised to 1 over m, or actually, sorry, a raised to negative m power, that's going to be the same as 1 over a raised to m, right? It's the reciprocal. The negative exponent is the reciprocal of the positive. So in this case, it's going to be 1 over 25 raised to the power of 3 halves. Okay, and now we can use the exact same property that we used in our last problem, in that this will be the same as a n over m, right? So this will be 1 over the square root of 25 cubed, and 25 cubed is it's the square root of, we're going to take the square root of 15,625. Okay, so again, that's 25 cubed. Now we're going to take the square root of this. And the square root of 15,625 is 1 plus or minus 125. Okay, so that's just a basic review of exponent properties.